Hello, this will be a demonstration of proposition 29 from book 6 of Euclid's Elements, which requires us to a given straight line, apply a parallelogram which is both equal to a given rectilineal figure and exceeds that straight line by a parallelogram similar to a given parallelogram. What this is going to look like is we're going to have some straight line AB like this, AB. We're going to have some arbitrary rectilineal figure, we're going to call it C, and we're going to have some parallelogram D. So a very similar setup to the previous proposition, but instead the task at hand for us is to apply a parallelogram to the straight line AB, which is equal to the rectilineal figure C and exceeds AB by a parallelogram similar to D. We're going to begin by bisecting the straight line AB at E, so that AE is equal to EB. We do that by proposition 110. Next, we're going to make the parallelogram BEFL similar to the parallelogram D. We do this by proposition 618. Like this. So this is going to be BEFL, like that. Now, next, we're going to make the parallelogram GH, which is equal to the parallelogram BF plus the rectilineal figure C, and similar to D. We do this by proposition 625, and we're going to make this parallelogram GHK such that, one moment to draw it out. We're going to make this parallelogram such that KH corresponds to FL and that KG corresponds to FE. So it's going to look like this. So this parallelogram right here is going to be equal to BF plus C, and it's going to be similar to D in such a way that KH is to KG just as FL is to FE. Now, because the parallelogram GH is greater than the parallelogram FB by common notion 5, right, FB is a part of the parallelogram GH, the other part being the rectilineal figure C. So naturally, the whole being greater than the part, the parallelogram GH is greater than the parallelogram FB, which means, again, by a proposition that should be here, but it's not, we can say that the straight line KH is greater than the straight line FL, and so too, the straight line KG is greater than the straight line FE. And what we're going to do with this, just going to move these letters down a bit, give myself a little bit more space. What we're going to do with this is we're going to make the straight line FLM like that equal to KH. And likewise, we're going to make the straight line FEN equal to KG. And we're going to complete this parallelogram by, we're going to complete this parallelogram by proposition, 131. That's it. Oh my goodness. I'm forgetting very obvious things right now. Okay. So, GH is similar to EL. We know this because the parallelogram EL was made similar to D, and the parallelogram GH was also made similar to D, so by 621, the two parallelograms EL and GH are similar to one another. One moment, I'm actually going to shorten this a little bit. Like that. So the parallelogram GH is similar to the parallelogram EL, which means that the parallelogram GH, which is similar to the parallelogram MN right here, this parallelogram here, which is similar to GH, is also similar to EL, and they have a common angle, which means by proposition 621, they will be about the same diameter. So we're going to make this diameter and call it FD. BO. We're going to join it by a postulate 1, of course. And we're going to describe the figure, and what that is going to look like is we're going to produce LB down like this, and we're also going to produce EB out like so. We're going to complete the parallelogram AN like this, and then we're going to have the gnomon XVW like this. So XWV. Again, it's ordered so strangely sometimes. Okay, so we have everything now. Okay, now the parallelogram GH, which is this parallelogram, is equal to the parallelogram EL plus the rectilineal figure C. We made it that way in our first step. And the parallelogram GH we had shown earlier is equal to the parallelogram MN, which means by common notion 1, parallelogram MN is likewise equal to the parallelogram EL plus the rectilineal figure C, which means that if we subtract EL from both of these by common notion 3, we will get equal remainders, which means that the rectilineal figure C is equal to this gnomon XWV. Now, the parallelogram AN is equal to the parallelogram NB because they are on equal bases, namely AE and EB, and they are in the same parallels, which means by proposition 136 they are equal to each other. And we also know by proposition 143 that the two parallelograms NB and LP are equal to each other because they are complements about the same diameter of the same parallelogram, which means we have two parallelograms which are equal to the same parallelogram. So common notion 1, they're equal to one another, which is that the parallelogram AN is equal to the parallelogram LP, which means if we add the parallelogram EO to both of them, the whole parallelogram AO will be equal to the gnomon XVW. But the gnomon XVW was shown to be equal to the rectilineal figure C, which means that common notion 1, the parallelogram AO is likewise equal to the rectilineal figure C, and it exceeds the given straight line AB by a parallelogrammic figure, namely BO, which is similar to the parallelogram D, which means we're done with the proposition. We have done that which we set out to do. To the given straight line AB, we have applied the parallelogram AO such that it is equal to the given rectilineal figure C and exceeding AB by the parallelogram BO, which is similar to D, which means we've done that which we set out to do, QEF. Now, similarly to the previous proposition, if we put this in algebraic terms, this is the solution to another quadratic equation. This one being very similar to the previous one, but instead of a minus sign, it's a plus sign. So we solve the quadratic equation AX plus B over C x squared is equal to S. Now I'm not going to go through how exactly you get this because it's very similar to the previous one. So it's a good exercise just to go through this and put this in algebraic terms. But I also just don't want to make the video longer. These are exhausting props to do. They're very lengthy and just kind of tough and windy. So I'm not going to make the video any longer than it needs to be. So I'm done with the video, which means I'll end it right now and move on to proposition 630.